am Professor Oglapurkar. I welcome you all for this second lecture in electricity. Today we will consider more important topics of electricity, and I will explain you some techniques of solving good problems. In fact, we will solve good problems today. The most important concept in the study of current electricity is series and parallel combination of resistances. Series आणि पॅरलल यांचा नेमका अर्थ काय आहे ते नीट समजावून घेणं आवश्यक आहे. बऱ्याच वेळेला अनेक विद्यार्थ्यांच्या गैरसमजुती असतात. So see the correct meaning of the words series and parallel. You can see here, when two or more resistances are connected in a circuit such that the same current, remember, same current passes through each of the resistances used, we say that the resistances are in series. Series चा नीट अर्थ काय? सेम करंट. एवढंच लक्षात ठेवा तरी वाचवीन. सिरीज म्हणजे सेम करंट. आणि मग पॅरललचा अर्थ काय? When two or more resistances are arranged in a circuit such that same potential difference is present across each of the resistances used, we say that the resistances are in parallel. So parallel means same PD across each resistance. नीट लक्षात ठेवा, पॅरललचा अर्थ काय? प्रत्येक रेजिस्टन्सच्या अक्रॉस पोटेन्शियल डिफरन्स सेम, नो अदर मीनिंग. Particularly, geometry of the arrangement of resistances is not important. Don't think that if the resistances are along the same line, they are in series. And if the resistances are along geometrically parallel lines, then they are in parallel. This is not true. Look at this figure. Here, resistances R1, R2 and R3 are along geometrically parallel lines, but they can be in series. How is it possible? Here the circuit is not complete. Now imagine that I complete the circuit as shown here. The circuit is complete here. Now what do you see? Current I delivered by the battery passes through R1. Same current I passes through R2. Same current I goes in R3 and returns to negative terminal of the battery or cell. So what do we see? Current in resistances R1, R2 and R3 is same current. So these resistances are in series. तर या ठिकाणी जरी रेजिस्टन्सेस जॉमेट्रीच्या दृष्टीने पॅरलल दिसत असले तरी ते खरे काय आहेत? सिरीज मध्ये आहेत. उलट. Now look at this figure. Here resistances R1, R2 and R3 are geometrically along the same line, but they need not be in series. These three resistances can be in parallel. How is it possible? For that, I complete the figure as shown here. The complete figure is here. Complete circuit is here. Now look at this figure. See the resistance R1. One end of R1 comes to positive terminal of the battery. Other end of R1 comes to negative terminal of battery. So what is PD across R1? Whatever is PD between terminals of the battery, that will be PD across R1. Look at R2. R2, one end of R2 comes to positive terminal of the battery. Other end of R2 goes to negative terminal of battery. So PD across R2 is same as PD between terminals of the battery. Finally, look at R3. One end of R3 comes to positive terminal of battery. Other end of R3 goes to negative terminal of the battery. So once again, PD across R3 is same as PD between terminals of the battery used. तर मग काय दिसलं या ठिकाणी? R1, R2, R3 यापैकी प्रत्येकाच्या दोन टोकामध्ये पोटेन्शियल डिफरन्स किती आहे? तर बॅटरीचा जो काय पोटेन्शियल डिफरन्स आहे तेवढाच. At once, it is clear that PD across each of the resistances R1, R2 and R3 is same PD. So resistances are in parallel. So these resistances, although geometrically they are along the same line, they are in parallel. मला वाटतं आता तुमचा आधीचा गैरसमज काय असेल तर तो नक्कीच नाहीसा झाला असेल की सिरीज म्हणजे एका ओळीत पाहिजेत आणि पॅरलल म्हणजे एका खाली एक पाहिजेत असं अजिबात नाही. महत्वाचं काय आहे? करंट सेम का पोटेन्शियल डिफरन्स सेम? करंट सेम असेल तर सिरीज, जॉमेट्री काही का असे ना. पोटेन्शियल डिफरन्स सेम असेल तर पॅरलल, जॉमेट्री काही का असे ना. I hope now you are very clear, and hereafter you will never make any mistake in understanding whether resistances are in series or they are in parallel. Now, it is important to learn and remember some characteristics of series and parallel combination of resistances. Here are important characteristics. You know very well formula for equivalent resistance or effective resistance. Yes. So first characteristic, when resistances are in series, equivalent resistance denoted by Req is R1 plus R2 plus R3, etc. In case of parallel combination, what is the formula? Reciprocal of equivalent resistance, that means 1 upon Req, is sum of reciprocals of individual resistances. So 1 upon Req is 1 upon R1 plus 1 upon R2 plus 1 upon R3, etc. हे दोन्ही फॉर्म्युले तुम्हाला तुमच्या पुस्तकावरून नक्कीच माहिती आहेत. पुढची माहिती महत्वाची आहे. If two resistances are in parallel, it is very convenient to remember Req equal to R1 R2 upon R1 plus R2 instead of 1 upon Req equal to 1 upon R1 plus 1 upon R2. It will be much convenient, much easier to remember this. Of course, the two equations are same, but this is more convenient. Next, the equation for equivalent resistance at once shows next two properties, next two characteristics. Equivalent resistance of a series combination is greater than the greatest of all the resistances used in series. म्हणजेच काय? R1, R2, R3 असे अनेक रेजिस्टन्सेस सिरीज मध्ये असतील तर Req R1 पेक्षा मोठा आहे, R2 पेक्षा मोठा आहे, R3 पेक्षा मोठा आहे. म्हणजेच त्या R1, R2, R3 पैकी जो सगळ्यात मोठा असेल त्याच्यापेक्षा जास्त आहे. पॅरलल बद्दल काय म्हणता येईल? पॅरललचा मगाचा फॉर्म्युला पहा, 1 upon Req इक्वल टू 1 upon R1 प्लस 1 upon R2 वगैरे. लगेच लक्षात येईल 1 upon Req 1 upon R1 पेक्षा मोठा, म्हणजेच Req R1 पेक्षा लहान, तसंच Req R2 पेक्षा लहान, R3 पेक्षा लहान. मग सगळं एकदम काय म्हणता येईल की R1, R2, R3 वगैरे या सगळ्यापैकी जो लहान आहे त्याच्याही पेक्षा REQ लहान आहे. सो वी से इक्विव्हॅलंट रेझिस्टन्स of a parallel combination is smaller than the smallest of all resistances connected in parallel. Remember these two things while solving problems. This will be useful. This will help you to avoid mistakes. See some more properties. If two equal resistances are in series, then REQ will be R plus R, that is 2R. REQ will be 2R. If three equal resistances are in series, REQ will be 3R. In general, if n equal resistances are in series, what we will get? REQ equal to n into R. Parallel साठी बरोबर उलट आहे. If two equal resistances are in parallel, our formula gives 1 upon REQ equal to 1 upon R1 plus 1 upon R1. म्हणजेच 1 upon REQ equal to 2 upon R. At once, this shows REQ will be R upon 2. Equal resistance series मध्ये REQ equal to 2R. Equal resistance parallel मध्ये REQ equal to R upon 2. If three equal resistances are in parallel, we will get REQ equal to R upon 3. In general, if we have n equal resistances in parallel, the result will be REQ equal to R upon n. So remember all these characteristics of series and parallel combination of resistances. Whenever this topic on current electricity is in the syllabus, any question paper is bound to contain problems on series and parallel combination of resistances. Large variety of problems. Particularly, if you are ambitious of getting some good result in a competitive examination, the problems that we discuss here will be quite useful to you. Now consider this problem P1. Two figures are given to us, figure 1, figure 2. In each figure, you have to calculate current in each resistance and also potential difference across each resistance. Look at the two figures carefully. First consider figure 1. In figure 1, what do you see? Resistances 20 and 10 are in series. So equivalent resistance from A to D will be 20 plus 10, 30. Similarly, 40 and 20 ohm resistances are in series. So equivalent resistance from A to D in this branch will be 40 plus 20, 60. Then this 30 ohm and this 60 ohm will be in parallel. So what will be equivalent resistance of the complete circuit of figure 1? Solution is given here. Equivalent resistance will be parallel combination of 30 and 60. मग असा फॉर्म्युला वापरला R1 R2 upon R1 plus R2, 30 into 60 divided by 30 plus 60, we get 20 ohm. Equivalent resistance of complete circuit is 20. So what will be current supplied by the battery? Current supplied by the battery by using Ohm's law. Current I equal to V upon R, 6 upon 20. So current supplied by the battery is 0.3 ampere. Now, what will be current in branch AB? or in branch BD. AB आणि BD मधला करंट किती? पोटेन्शियल डिफरन्स आहे 6 व्होल्ट, रेजिस्टन्स आहे 30 ओम. मग करंट काय आला? 6/30 ओम्स लॉ वन्स अगेन 6/30, सो 0.2 एम्पियर. तेव्हा ए पासून बी पर्यंत करंट किंवा बी पासून डी पर्यंत करंट प्रत्येकी 0.2 एम्पियर. पुढच्या दोन रेजिस्टन्स मधला करंट 20 आणि 40, एकूण रेजिस्टन्स आहे 60. सो करंट फ्रॉम ए टू सी or current from C to D will be potential difference V 6 divided by resistance 60. So current is 0.1 ampere. So in this way we obtain current in each resistance. Now potential difference across each resistance, again we are using Ohm's law, V equal to IR. So VAB, current I is 0.2. Resistance R is 20. V equal to IR. So VAB is 0.2 into 20, 4 volt. VBD, again Ohm's law, current 0.2, resistance 10. So potential difference is 2 volt. Next, VAC, between A and C current is 0.1, resistance is 40. So VAC is 0.1 into 40, 4 volt. VCD, current is 0.1, resistance is 20. So VCD is 2 volt. So in this way we have calculated potential difference across each resistance. Finally, look at this. VAB 4 volt, VAC 4 volt. Obviously, it means that points B and C are at same potential. Potential at B and potential at C is equal. हे लक्षात ठेवणं महत्वाचं आहे. B आणि C चा potential difference सारखा आहे. So this is all about figure 1. Now look at figure 2. फिगर 2 साठी आपल्याला परत प्रत्येक रेजिस्टन्स मधला करंट आणि प्रत्येक रेजिस्टन्सच्या दोन टोकांमधला पोटेन्शियल डिफरन्स कॅल्क्युलेट करायचा आहे. लुक ॲट फिगर 2. 20, 40 are in parallel. So equivalent resistance will be 20 into 40 divided by 20 plus 40. Calculation you can do easily. Then 10 and 20 are in parallel. So equivalent resistance will be 10 into 20 divided by 10 plus 20. Then parallel combination of 20-40 is in series with parallel combination of 10 and 20. Here is the calculation. Yes, this is calculation for figure 2. 20 and 40 parallel, equivalent resistance 40/3. 10 and 20 in parallel, equivalent resistance 20/3. These two are in series, so equivalent resistance of complete circuit of figure 2, 40/3 plus 20/3. That comes out to be 20 ohm. This is equivalent resistance of entire circuit shown in figure 2. So how much current is supplied by the battery? Ohm's law. It is all repetition now. So current is V upon R. V is 6, R is 20. So current supplied by battery is 0.3 ampere. Now because of this current, what will be potential difference from A to B? Same as A to C. Ohm's law once again. V equal to IR. I is 0.3, R is 40/3. So potential difference is 4 volt. Same way, potential difference from B to D or C to D, VBD or VCD. Current is 0.3, resistance is 20/3. So potential difference is 2 volt. So we have obtained potential difference across each of the resistances shown in figure 2. Now current. Current from A to B, Ohm's law once again. V is 4 divided by R is 20, so 0.2 ampere. Current from B to D, V is 2, R is 10, so 2 upon 10, 0.2 ampere. Current from A to C, V is 4, R is 40, so 0.1 ampere. Finally, current in C to D, V is 2, R is 20, so 0.1 ampere. At once, B and C are together, so potential at B and potential at C are same. And because potential at B and C are same, what will be current from B to C? 0. Current flows from higher potential to lower potential. If B and C points are at same potential, no current will flow from B to C. So current from B to C is 0. Now, complete solution of figure 1. What is current in each resistance? What is PD across each resistance? That is shown in this figure 3. Figure 1 मधल्या प्रत्येक रेझिस्टन्स मधला करंट आणि प्रत्येक रेझिस्टन्सच्या दोन टोकांमधला पोटेन्शियल डिफरन्स त्या फिगर 3 मध्ये दाखवला आहे. In the same way, current in each resistance of figure 2 and PD across each resistance of figure 2 is shown in figure 4. Figure 2 मधल्या प्रत्येक रेझिस्टन्स मधला करंट आणि प्रत्येक रेझिस्टन्सच्या दोन टोकांमधला पोटेन्शियल डिफरन्स हा फिगर 4 मध्ये दाखवला आहे. Look at figures 3 and 4 carefully. Compare carefully. This is figure 3 and here is figure 4. A careful inspection of figure 3 and figure 4 shows that in both the figures, current in respective resistances are same and also potential difference across respective resistances are same. Figure 3, figure 4 दोन्ही मध्ये करंट्स तेच आहेत, potential difference ही तेच आहेत. Why does it happen? Figure 1 and figure 2 are quite different. Figure 1, figure 2 अगदी वेगळ्या दिसतात, पण सगळे करंट्स आणि सगळे पोटेन्शियल डिफरन्स अगदी सारखे आलेले आहेत. So what do we observe? Our solution of figure 1 and figure 3 are exactly same. Why this happens? The reason is points B and C are at same potential, VB equal to VC. Same reason, put in other words, current between B and C is 0. No current flows between points B and C. Very interesting and very important conclusion. Remember these two conclusions. Very useful in solving problems. If 2 points of a circuit are at same potential, these 2 points can be joined without affecting current and voltages anywhere in the circuit. Second conclusion, in fact the same conclusion put in other words. If current in a certain branch of a circuit is 0, that branch can be removed without affecting currents and voltages anywhere in the circuit. ही दोन कन्फ्युजन समजली का? तर परत एकदा फिगर 1 फिगर 2 पहा. बघा परत एकदा फिगर 1 फिगर 2. प्रॉब्लेम सोडवल्यानंतर आपल्या काय लक्षात आलं की दोन्ही मधले करंट्स आणि व्होल्टेजेस हा अगदी एकसारखे आहेत. आफ्टर सॉल्विंग दिस प्रॉब्लेम what we come to understand is currents and voltages in the two figures are exactly identical. So what can we say? In figure 1, B and C are at same potential. So these 2 points can be joined. That gives figure 2. After we join B and C, we get figure 2. So if we join points B and C, There is no change in current, no change in potential difference anywhere in the circuit. Other way, figure 2 is same as figure 1. In figure 2, current between B and C is 0. And because current between B and C is 0, we can remove branch BC. That gives figure 1. If we remove branch BC, we get figure 1. And if I do that, currents and voltage anywhere in the circuit is not affected. So these two conclusions are important. These two conclusions will help us in solving good problems. Ambitious students should always use this to solve high-level problems, good problems. Let us see next problem where this will be useful. Now next problem is, many students find this problem very difficult. But after we use this conclusion, the problem becomes quite easy. 12 wires, each having resistance R, are joined to form a cube. We have to find equivalent resistance of this cube between any two diagonally opposite corners of the cube. The cube is shown here. Let us find equivalent resistance between diagonally opposite corners P and Q. P and Q are diagonally opposite corners. To determine equivalent resistance between P and Q, we imagine a battery or a cell connected from P to Q. A cell or battery of potential difference V is connected between P and Q. Now, some current is delivered by the battery. At point P, the current will go partly in B, partly to A, partly to C. Now look at the figure. The figure is perfectly symmetric. Symmetry is important. Because of symmetry, there is no reason why current here should be greater, current here smaller, or current here different. Perfect symmetry. So, because of symmetry, we can expect that current going to B, C or A are equal. Symmetry मुळे P कडून A कडे, B कडे किंवा C कडे जाणारा करंट सारखाच असला पाहिजे. A कडे किंवा B कडे करंट वेगळा असण्याचं काही कारणच नाही. A कडे किंवा C कडे जाणारा करंट वेगळा असण्याचं काही कारणच नाही. Symmetry आहे. So let us imagine that current in PA, PB and PC is I. Obviously total current coming to point P must be 3I. P कडून A कडे करंट I, B कडे I, C कडे I. म्हणजेच बॅटरी मधून P कडे येणारा करंट असला पाहिजे 3I. Whatever current starts from positive terminal of battery, same current must return to negative terminal of battery. So current 3I returns. Current in this part of the circuit is 3I. Now look at point Q. Once again, perfect symmetry. AQ, A1Q, B1Q and C1Q are identical. A1 कडून Q कडे जी कंडिशन आहे तीच कंडिशन B1 कडून Q कडे आहे, तीच कंडिशन C1 कडून Q कडे आहे. Once again, there is perfect symmetry. So due to symmetry, currents coming to Q from three corners A1, B1 and C1 must be equal. Symmetry मुळे A1 कडून, B1 कडून, C1 कडून Q कडे येणारा करंट सारखा असला पाहिजे आणि टोटल 3I आहे. म्हणजेच प्रत्येक करंट झाला I. एव्हरी करंट इज I. आता आपल्याला करंटचं डिस्ट्रीब्युशन कळालं. Now what about potential difference? Potential difference also called voltage. What about voltage? P to A, current is I, resistance is R. So voltage I into R. P to B, current is I, resistance R. So voltage I into R. P to C, current is I, resistance is R. So voltage I into R. At once, what we find is points A, B and C are at same potential. A, B आणि C पॉइंटचं व्होल्टेज सारखं आहे. So from the conclusion of previous problem, points A, B and C can be joined because they are at same potential. For the same reason, potential at A1, potential at B1 and potential at C1 will be equal, each I into R. So once again, points A1, B1, C1 are at same potential, so they can be joined. Now the situation is, resistance of each edge is R. Points A, B, C can be joined together. Points A1, B1, C1 can be joined together. After we do this, figure 1 will reduce to figure 2. P कडून A, B, C तिन्ही एकत्र दाखवले तिथे. तेव्हा PA रेझिस्टन्स R, PB रेझिस्टन्स R, PC resistance R. At once you find that these three resistances are in parallel. Next, A1, B1, C1 are together. Now resistance from A1 to Q is R, resistance from B1 to Q is R, resistance from C1 to Q is R. So these three are once again in parallel. Out of 12 edges, 3 here, 3 here, all the 6 remaining. Each of the remaining 6 edges is from either of A, B, C to either of A1, B1, C1. So all these 6 resistances, each equal to R, appears between A, B, C together and A1, B1, C1 together. Yes, you are right, that these 6 resistances are in parallel. So what is the net situation? That is shown in figure 3. Resistance from P to ABC is R, parallel, so R upon 3. Resistance from ABC to A1, B1, C1, R 6 times in parallel, so equivalent R upon 6. Finally, from A1, B1, C1 to Q, again 3 resistances in parallel, so equivalent R upon 3. So total situation is here. Finally, it is at once clear that these R upon 3, R upon 6, R upon 3 are in series. So what is the equivalent resistance between diagonally opposite corners P and Q? Equivalent resistance from P to Q will be series. So R upon 3 plus R upon 6 plus R upon 3. Answer 5R upon 6. हा अवघड प्रॉब्लेम किती सोपा झाला मगाशच्या आपण कन्क्लुजन वापरल्यामुळे. The problem that normally appears very difficult, now it has become very easy because we are using the conclusions of the previous problem. Points at same potential can be joined without affecting currents and voltages anywhere in the circuit. Let us come to another interesting problem. Such a problem many times appears in high level competitive examinations. In this figure, you are given an infinite ladder. मराठीत आपण शिडी म्हणतो. शिडीसारखी ही फिगर दिसते. Infinite ladder. So it contains infinite number of resistances each equal to R. असंख्य रेजिस्टन्सेस आहेत, प्रत्येक व्हॅल्यू R, आणि ते असंख्य रेजिस्टन्सेस अशा प्रकारे अरेंज केलेले आहेत. We have to find equivalent resistance of this infinite ladder. The word infinite has to be understood carefully. Infinite शब्दाचा अर्थ नीट लक्षात ठेवला पाहिजे. Infinity, अनंत. If you add anything to infinity, what is the result? Infinity only. If you remove anything from infinity, what is the result? Infinity. No change. समुद्राच्या पाण्यात एक तांब्यावर पाणी ओतलं म्हणून काही समुद्राची पातळी वाढत नाही. इन्फिनिटी मध्ये आपण काहीतरी ऍड केलं म्हणून रिझल्ट काय? इन्फिनिटी. समुद्रातनं तांब्यावर पाणी कमी केलं किंवा बादलीवर पाणी कमी केलं तरी समुद्राची पातळी काही कमी होणार नाहीये. सो इफ यू रिमूव्ह समथिंग फ्रॉम इन्फिनिटी, रिझल्ट इज इन्फिनिटी. हे लक्षात ठेवायचं. नाउ लुक ॲट फिगर 1. I delete this first part of the figure, R. Excluding this first part, what is the remaining circuit? Again infinite ladder. यातला पहिला पार्ट काढून टाकला म्हणून इन्फिनिटी काही फरक होत नाही. So imagine that equivalent resistance of this infinite ladder is Req. So what will be equivalent resistance after we remove this first part? Equivalent resistance of the remaining Req. इन्फिनिटीतला एवढा पार्ट काढून टाकल्याने त्यात काही फरक पडलेला नाही, त्यामुळे उरलेल्या लॅडरचा रेजिस्टन्स Req आहे. नाउ द अरेंजमेंट लुक्स लाईक फिगर 2. फर्स्ट थ्री रेजिस्टन्सेस R, no change. After that, what remains the infinite ladder? It is equivalent to resistance Req. What is resistance from this to this? Req again. Now, you have to solve simple equation. In figure 2, at once you see that this resistance R and Req are in parallel. Then these are this parallel combination and these are they are in series. So resistance here Req, that must be equal to R plus parallel combination R into Req divided by R plus Req, and then again plus R. Here is the equation. Req is R plus parallel combination of R and Req, R into Req divided by R plus Req plus R. Now what remains is only mathematics. Physics is over, electricity part is over. आता काय करायचंय? हे इक्वेशन सॉल्व करायचंय. राहिलं काय? सिंपल अल्जेब्रा. Yes, you get quadratic equation. There is a term in R square Eq, there is a term containing Req, and there are some terms not containing Req. Rearrange the quadratic equation. What you get is Req square minus 2R into Req minus 2R square is 0. Use quadratic formula. After you use quadratic formula and solve, you get Req equal to, here is the solution. Simplify like this and finally like this. So Req is resistance small r into bracket 1 plus root 3. हा सगळा पार्ट सिंपल अल्जेब्रा आहे, quadratic equation. I am sure you are expert in solving quadratic equation. यातनं महत्वाचं काय शिकलो आपण? इन्फिनिटीची कल्पना काळजीपूर्वक आणि नीटपणे वापरायचे. अँड देन द थिंग्स अपीअर इझी. यूज द कन्सेप्ट ऑफ इन्फिनिटी केअरफुली, करेक्टली, अँड देन एव्हरीथिंग बिकम्स सिंपल. Let us come to one more problem where we use other conclusion of the previous problem. Other conclusion. Once again, we have 12 edges, each having resistance R in the form of a cube. But in this problem, we have to find equivalent resistance between diagonally opposite points of a face, not diagonally opposite corners of the cube. We have to find equivalent resistance between two ends of diagonal of a face. मला असताना हा प्रॉब्लेम वेगळा आहे. मगाशी आपण क्यूबचे डायगोनली ऑपोजिट कॉर्नर घेतले होते. आता आपण काय घेतोय? कोणत्या तरी एका सरफेसचे डायगोनल. इफ वी कन्सिडर टॉप सरफेस, वी कॅन यूज or we can think diagonally opposite points P and R. So now we have to find equivalent resistance between points, between corners P and R. Consider distribution of currents very carefully. All your thinking is here. All your talent is here. Your experience, your expertise of solving problems is here. Calculation करना काही आवड नाही आहे. ह्या फिगरमध्ये योग्य प्रकारे करंटचं डिस्ट्रीब्युशन करणं हे महत्वाचं आहे. त्यात आपली बुद्धिमत्ता दिसते, त्यात आपली प्रॅक्टिस, आपला एक्सपिरियन्स सगळं काही दिसतं. ऑफकोर्स द थिंग इज डिफिकल्ट. वन्स यू हॅव डेव्हलप्ड correct thinking, everything becomes easy. Okay, look at this figure. Suppose current coming at corner P is I. Because of symmetry, whatever is current here, same will be current here. But now symmetry is only from P to Q or P to S, not here. Situation on this side and on this side is different. But whatever is situation here, same is situation here. So because of symmetry, current from P to Q and current from P to S is same, identical. Suppose I1. So current here is I1, current here is I1. What will be current here? Out of current I, current I1 goes P to Q, another current I1 goes P to S. So remaining current will go from P to P1. Remaining means I minus twice I1. I पैकी I1 इकडे गेला, आणखी एक I1 इकडे गेला, उरलेला करंट I minus 2I1 हा P कडून P1 कडे आलेला आहे. Now look at the other end. Whatever current enters at P, same current leaves from R. So current that leaves the corner I is I. Because of symmetry, current in QR and SR must be equal. Again I1. And current in R1 to R must be I minus 2I1. Same thinking whatever we are used here. Whatever thinking we are used here, same thinking we are using at corner I. So what is the next situation? Next situation is current P to Q is I1. Current P to S, I1. Current Q to R, I1. Current S to R, I1. This distribution of currents is very important. What is the importance? Once again see carefully. Current from P to S, I1. Current from S to R, I1. P कडून S कडे I1 करंट आला. S कडून R कडे I1 करंट गेला. उरलेला करंट इकडे जाणार आहे. काय उरला? I1 आला आणि इकडे I1 गेला, म्हणजे काहीच उरलं नाहीये. So current in S to S1 will be 0. Nothing remains. Current here is I1, current here is also I1, and remaining current must be here. But remaining means 0. I1 minus I1. So current from S to S1 is 0. For the same reason, current from Q to Q1 is 0. No current flows from S to S1, Q to Q1. See the second conclusion of problem number 1. If no current flows in a certain branch, that branch can be removed. That branch can be removed without affecting currents and voltages anywhere in the circuit. तेव्हा P1 प्रॉब्लेमचं दुसरं कंक्लुजन वापरलं की काय होईल? S1 ही ब्रँच काढून टाकता येईल. Q1 ही ब्रँच काढून टाकता येईल. तसं केल्यामुळे सर्किटच्या इतर भागामध्ये कुठेही करंट किंवा व्होल्टेजमध्ये फरक पडणार नाहीये. So after we remove branches S1 and Q1, the arrangement looks like figure 2. Here is the arrangement. It is same as figure 1. Only thing is we have removed branch S to S1 and we have removed branch Q to Q1. Now look at figure 2. PQ, QR. They are of course in series. Whatever is current from P to Q, same must be current from Q to R. Similarly, PS, SR are in series. Then series combination PQR is in parallel with series combination PSR. Same thing repeated on the lower side. P1 Q1 and Q1 R1 are in series. P1 S1, S1 R1 series. And then P1 Q1 R1 is in parallel with P1 S1 R1. After we do all this, figure 2 can be reduced to figure 3. Here is figure 3. P2 R, resistance R plus R. P2R, other branch, resistance again R plus R. So PQR, two resistances RR. PSR, two resistances RR. Same thing here. P1 Q1 R1, two resistances RR. P1 S1 R1, two resistances is equal to R. Now what remains is this R and R together 2R, this R and R together 2R. Similarly, here 2R and here 2R. After we do that, we get figure 4. Now 2R in parallel, so equivalent resistance R, that is shown here. Again 2R parallel, equivalent resistance R, that is shown here. So this figure 4 can be further simplified as shown in figure 5. Last step. In figure 5, these are, they are in series. So total resistance of this branch is R plus R plus R, 3R. And that 3R is in parallel with this R. Calculation is at once obvious. So equivalent resistance will be R in parallel with R plus R plus R. So using formula for parallel combination, equivalent resistance comes out to be 3R upon 4. 3R upon 4. Come to next problem. The problem appears simple, but it has important applications. In this figure, a cell or a battery Vs supply voltage is connected to resistances R1, R2. We have to calculate output voltage VO across resistance R2, or output voltage between terminals A and B. Calculation is no doubt easy. Understanding is also easy. At once we see that R1 and R2 are in series. So total resistance R1 plus R2. So what should be current I? Supply voltage Vs divided by R1 plus R2. That will be current I. And then what will be? Output voltage between terminals AB. Ohm's law. Current I into R2. Current I is V divided by R1 plus R2. This current multiplied by R2, that will be output voltage. Here is the calculation. Current I is supply voltage divided by R1 plus R2. Supply voltage divided by R1 plus R2. Output voltage is current I into R2. We put this value of I, rearrange. The final result is output voltage VO is R2 divided by R1 plus R2 multiplied by supply voltage Vs. This is the result. You will say this is easy. Yes, no doubt it is easy. But the purpose of taking this problem is, look at the final result. Output voltage VO is fraction R2 upon R1 plus R2. It's a fraction. A fraction of supply voltage Vs. By choosing convenient values of R1 and R2, we can have any desired fraction, R2 upon R1 plus R2, any desired fraction of Vs. So output voltage can be any desired fraction of Vs. If I desire, output voltage should be 1/10 of Vs. I will take R2, say 10 ohm, and R1, 90 ohm. 10 divided by 90 plus 10. So 10 upon 100, so 1/10. So any fraction, 1/10, 1/4, 3 by 14, any fraction of supply voltage can be developed. That conclusion is here. This is the comment. By choosing suitable values of R1 and R2, we can get output voltage equal to any desired fraction of supply voltage Vs. Suppose we are using 6 volt battery and we need output voltage 0.7. Yes, we can choose proper value of R1, R2 to get 0.7 volt. Sometimes we may need 1.3 volt. Sometimes we may need this or this. Any desired output voltage, of course fraction of 6, less than 6, not more than 6. Any voltage less than 6, somebody may think 3.5, somebody may think 4.9. Yes, possible. तेव्हा 6 पेक्षा कमी कोणतेही व्होल्टेज, कोणाला 1.3 पाहिजे, कोणाला 3 पाहिजे, कोणाला 4.9 पाहिजे, शक्य आहे. R1, R2 च्या योग्य व्हॅल्यूज वापरून पाहिजे ते आउटपुट व्होल्टेज 6 पेक्षा कमी आपल्याला मिळवता येईल. This type of arrangement is extensively used in electronic circuits. In electronic circuits, so many times you will find the arrangement that was shown here, this type of arrangement. This arrangement of resistances R1 and R2 divides supply voltage by any fraction and gives expected output voltage. So this type of arrangement is very popularly known as voltage divider. This is called voltage divider circuit. Very, very extensively used in electronic circuits. If you have understood these problems, you can try these activities. Look at this figure. I need not give complete explanation, but you can at once understand that this 30 ohm resistance can be removed. Current here is 0. Similarly, this 30 ohm resistance can be removed. Current here is 0. And after you remove, the solution is at once obvious. Next activity. Infinite ladder. So whatever problem P2, second problem we solved, same method you can use for this infinite ladder. Next activity. Interesting. We will find this type of figure in many competitive examination objective questions. What is the equivalent resistance from P to Q? A slight thinking will show these 2 points are at same potential. This point and this point are at same potential. So we can remove this branch. This resistance can be removed. And after you remove this, answer is obvious. These are series, so 2R. These are series, so another 2R. This R is removed. These 2R and these 2R are in parallel. So equivalent resistance R. Answer is simple, R. In the same way, you can try this. Here, R and R series, so 2R. That 2R and this 2R parallel, so R. That R and this R series, so 2R. That 2R and this 2R parallel, so R. That R and this R series, so 2R. You can calculate current or whatever you require. I hope you have enjoyed all these problems. Solve these problems again and again. See that you have understood these problems. If you have any difficulty, don't hesitate to consult your teacher or any senior person. हे सगळे प्रॉब्लेम नीट समजावून घ्यायचे. समजले नसतील तर आपल्या टीचरना विचारा, इतर कोणाला विचारा, नीट समजावून घ्या, प्रॅक्टिस करा. I am sure after you have understood these problems, you can face any competitive examination in a very confident manner. I hope you are ambitious to give competitive examinations, maybe Maharashtra Talent examination, Maharashtra Olympiad examination arranged by MKCL, or national standard examination in junior science, astronomy, arranged by IAPT. You can face all these examinations very confidently. तेव्हा कुठल्याही कॉम्पिटेटिव्ह एक्झामिनेशनसाठी आणि तुमच्या नेहमीच्या 8वी 9वी 10वीच्या परीक्षांसाठी माझ्या मनपूर्वक शुभेच्छा. गुड लक.